Hi, welcome to another 4AC learning video. In this video, we want to look at example 2.2b, which is found in your lecture notes. The question reads, the current through a 0.2 Henry coil is given as IL equals to 4 sine bracket 20t plus 40 degrees. So we want to find the sinusoidal expression for the voltage across the coil, and we also want to sketch the voltage VL and the current IL curves. So how should we answer this type of question? Let's have a look at this. Well, to answer this question, I will first draw a circuit of what we are looking at. So the first thing we'll do is to draw the circuit. So we have an inductor, and we are told or given that the current flowing through the inductor is 4 sine 20t plus 40 degrees ampere. Okay, and the value of the inductor is 0.2 Henry. Now, if you were to compare our standard current waveform, we have I peak, or in this example here is I maximum, sine omega t plus a phase angle. So looking at this, the peak value of the current is 4 ampere. So IL maximum is 4 ampere. And we also know that omega, from the comparison, omega is 20 radian per second. So the inductance reactance XL is dependent on the frequency, so which is omega L. So I can calculate XL based on omega L. That's 20 radian per second multiplied by 0.1 Henry. So that gives me 0.2. I apologize, 0.2 Henry. That gives me 4 ohms. Now VL, the maximum value of the, can be calculated by using Ohm's law. So IL maximum multiplied by the reactance XL. So that's equals to 4 times 4, which is 16 volt. Now we know that the current for inside in the inductive circuit lags the voltage by 90 degrees, which means that if I were to write the waveform, which is the standard waveform, I will have to put in V peak sine omega t plus the existing waveform and another 90 degrees to it. Since I calculated V peak here, so 16 comes here, and omega t doesn't change in a AC circuit, so the original omega t is 20t, so we still continue with the 20t, but the angle is added up, so we have 130. Okay, so that's how the voltage sinusoidal waveform is derived. Now, when we come to drawing the circuit, right, we have the voltage waveform, which leads the current waveform by 90 degrees. That means from here to here, the difference is 90 degrees. And the current waveform has a shift of 40 degrees. That means at this point is minus 40 degrees. Right? And the maximum value of the current is 4 amps. Here is 4 amps, whereas here is 16 volt maximum. So here is minus 130 degrees. So that's the waveform of the current and the voltage, current and voltage across the inductor. VL, T, and ILT. Okay, so that's all for me for this question. I hope you know how we determine the voltage and current waveform for an inductive circuit. Bye bye.